Picture this, all right? You're a helicopter pilot, you're in some pretty hostile territory, and all of a sudden, you see a missile launch. I mean, we see this all the time in movies, right? It's dramatic, it's intense.
Yeah, it's Hollywood for sure.
But in reality, this is a very serious threat,
Mm.
especially now with more and more of those portable missile systems, those man pads out there.
Oh, absolutely. It's not just about major militaries anymore. You
Right.
know, these things are a problem in so many different places these days.
And that's what we're going to deep dive into today, right? We're talking directed infrared countermeasure systems, or, DRCM.
DIRCM.
And it's not just about popping flares and crossing your fingers anymore. DRCM is way more precise. It's using lasers, actual lasers, to mess with the guidance system of an incoming missile.
Pretty wild stuff, right?
It sounds like straight up science fiction. Lasers shooting down missiles.
It does have that sci-fi feel to it, for sure.
Yeah.
But it all comes down to, well, physics, good old-fashioned physics and engineering. Instead of, flooding the area with that infrared signature from flares, DIRCM focuses a beam, just a really precise beam of energy, right onto that missile sensor.
Exactly. And today, we're going to figure out why this really sophisticated technology is so important for modern aircraft, especially for India's light combat helicopter, the LCH, developed by, of course, Hindustan Aeronautics Limited. We'll call them HAL for short.
Makes sense.
So this LCH, it's a twin-engine helicopter, weighs about 5,800 kilos, and it's meant to do a whole bunch of different military jobs.
Multi-role, yeah, very versatile.
Our mission today is to understand why they're developing DIRCM for this helicopter and how the heck it actually works. We've got some really cool information here that'll give you a clear picture of how these cutting-edge defense systems are put together and integrated.
What's fascinating to me is how this all plays out,
Yeah.
You've got this threat, this constant evolving threat, and then this really high-tech response to it. And understanding that dynamic, well, it's key to seeing just how important DRCM really is.
Okay, so let's break this down a bit. First, the problem. Those infrared missiles. You mentioned man pads before. That's a pretty specific kind of danger, right?
Yeah, man-pads. So that's man-portable air defense systems. Exactly what it sounds like. These missiles, they're light enough that one person can carry them and fire them.
So, one person is all it takes to launch this thing. Wow.
Exactly. And because they're so, portable and easy to use, they're a real threat, especially to helicopters or any aircraft flying low, in areas where things aren't secure.
Right. So if you're a pilot in certain parts of the world, these things are a big deal. And traditionally, how are we defended against them? Flares, right?
Right, flares. You release this big burst of heat trying to confuse the missile's targeting.
But you said those aren't as effective now. Why is that? What's changed?
The missiles themselves. The seeker technology, it's gotten a lot better. These newer infrared seekers, they're much smarter. They can tell the difference between the heat from a flare, which is really broad and fades quickly, and the heat from an aircraft's engine, which is more focused and constant.
So, the flare is a distraction, but the missile can now see through it.
Exactly. It's like the inverse square law in action, The energy from a flare, it spreads out fast, gets weaker as it goes further. A smart missile can ignore that and stay locked on the aircraft.
Okay, I'm starting to see why flares might not be enough anymore, but that's where DRCM comes in, right? So how does it actually stop these smarter missiles?
It's a sequence, a very clever sequence. First, you got to take the missile. So the aircraft has these sensors, usually part of the Missile Approach Warning System. We call it MAWS. These are designed to pick up the infrared signature of a missile launch, right when it happens.
So the idea is to give the pilots as much warning as possible.
As much as possible, yeah. And these systems use infrared sensors, sometimes ultraviolet too, to pick up that unique heat from the missile. So once the system confirms a launch, it moves to the tracking phase.
Tracking, okay.
It uses some pretty sophisticated tech, often linked to the aircraft's electronic warfare suite, to lock onto that missile and keep track of where it's going.
So it's like a super advanced targeting system, but for defense.
Exactly. It's targeting the threat.
Yeah.
And then we get to the part that sounds like sci-fi, jamming with lasers.
This is the part I've been waiting for.
So the DIRCM system, it fires this modulated laser beam. It's in the infrared spectrum, aimed right at the missile seeker.
But it's not just a constant beam, right? You said modulated.
Yeah, it's not just a light show. The beam is coded specifically to mess with how the missile understands infrared signals. Basically, it overloads the seeker, blinds it, so it loses its lock on the aircraft.
So instead of tricking the missile, with a flare, you're blinding it.
That's a good way to put it. And remember how we talked about those advanced seekers seeing through flares? This laser energy, it's targeted, it's modulated, it's much harder for the missile to ignore.
Wow. And some DRCM systems can even handle multiple missiles at once, right?
Absolutely. Some systems have multiple turrets that can each aim independently, so they can counter several missiles coming in at the same time. In modern combat, coordinated attacks are a real possibility, so this multi-threat capability is essential.
That's a huge advantage. So just to sum up what we've got with DIRCM, it's really precise. You basically have unlimited ammo because it's laser energy and it does all this automatically. That's a big jump from those old countermeasures.
It's a total game changer for aircraft defense. Targeting means you're using energy efficiently, directly countering the threat. And because it's laser-based, you don't have to worry about running out of flares or anything like that. Though, it does depend on the aircraft's power system. And being automatic, that's super important. It means the system reacts fast, effectively, without the crew having to do a bunch of stuff in a high-stress situation.
It takes a huge load off the pilots, for sure. Okay, so let's bring this back to the LCH. Why is DRCM so important for this helicopter specifically?
The LCH, it's designed for some pretty intense missions. We're talking combat search and rescue, anti-tank operations, counterinsurgency. All these happen in places where, well, infrared-guided missiles are a real and constant danger. Protecting the LCH and the crew, that's crucial. If they're going to succeed, if they're going to survive, they need this protection.
And that's why HAL, the company that makes the LCH, is working on a DRCM system just for it, right? This isn't something they're just buying off the shelf.
No, it's not off the shelf. They're taking a co-development approach.
Co-development. Interesting.
So they're working with a global leader in this field, a company that really knows DRCM. This way, HAL can tap into that existing technology and know-how, and at the same time, Indy gets to build its own skills in this area, which is really important. They're planning to do this whole co-development phase in about 30 months, and then they want to start making something like 180 DRCM units, maybe around 2026 or 2027.
Those are some serious numbers. It shows they're really committed to this. But how are they going to actually make this DRCM system work with the LCH? It's not just a separate thing they bolt on, right?
No, not at all. It has to be integrated with the aircraft's other systems, with its avionics and electronic warfare systems, especially with the MAWS, the Missile Approach Warning System we talked about before.
Okay, right. That makes sense.
These systems, they need to talk to each other, share information, and they do that using these standard communication protocols, things like RS-422 and MLSTD-1453.
Ah, yes, the alphabet soup of military standards.
Basically, these are established ways to make sure that different electronic systems on the aircraft can talk to each other reliably, securely. And that's absolutely vital for a defense system like this.
What kind of data are we talking about here? What information needs to go back and forth?
Well, first you've got the aircraft's navigation data. Its position, its orientation, how it's moving, roll, pitch, yaw, all those things. That way, the DRCM system knows where the aircraft is and where it's going. And then, really important, the MAWS will tell the DRCM about the threat. Which direction the missile's coming from, how long until it hits. That lets the DRCM system aim the laser quickly and accurately.
So it's a coordinated defense. The MAWS sees the threat, tells the DRCM where to point the laser.
Exactly. And all that information, it's displayed on the LCH's main display, the Integrated Avionics Display System. That way, the pilots have a clear picture of what's going on. They see the threat, they see how the system is responding, and that really helps them understand the situation.
Makes sense. So the documents also lay out this whole process for developing the DRCM system. What are the main stages involved in getting this onto the LCH?
It's a thorough process, as it should be. It starts with the design phase, of course.
Yeah.
Then you move into testing and qualification. That's where they make sure the system can actually do what it's supposed to do under all sorts of conditions. Then they have to do flight trials.
Right. Get it up in the air, see how it works for real.
Exactly. And then finally, the system needs to be certified before it could be fully deployed on all the LCHs.
So it's not just about building the hardware, it's about proving that it works and making sure it's safe to use.
Absolutely. And it's not just about the hardware either. The project also includes things like the test equipment needed to maintain the system, all the documentation, and really important training programs for the people who'll be using and maintaining it.
So it's the whole package, not just the box with the laser.
Right. It's the whole support structure. Now, once the system is developed and tested, HAL's avionics division will take over production and supply.
Okay, so they're going to be building these things themselves.
Yeah. The plan is to have about 25% of the systems delivered as completely built units. The other 75% HAL will assemble them using parts and subassemblies.
And I bet there's a big focus on making this in India, right?
Oh, definitely. The goal is to have at least 60% indigenous content in these DIRCM systems. That aligns with India's Defense Acquisition Procedure 2020 guidelines. This whole idea of indigenization, it's a key strategy for India's defense sector. And the company they're partnering with, they're actually required to transfer all the manufacturing technology and the know-how for repairs and overhauls to HAL.
So it's not just about getting the tech for now, it's about building the capability in India for the long term.
Exactly. They want to be able to sustain this, upgrade it, maybe even develop new versions down the line.
Now, we also mentioned Bharat Electronics Limited, or BAL, before. They're another Indian defense company, and they also make a DRCM system. How does that fit in?
BEL is a major player in India's defense electronics industry. They've developed their own laser-based DIRCM system, completely made in India. It's designed to protect all sorts of aircraft, including helicopters like the LCH, from those heat-seeking missiles, especially during critical moments like takeoff, landing, or when flying low.
So they're offering a homegrown solution alongside that co-developed system.
Right, and BEL emphasizes a few key things about their system. It's small, it's light, which makes it easier to integrate with different aircraft. It's got an open architecture, so it can work with lots of different warning and protection systems. And like the system for the LCH, it's automatic. The crew doesn't have to manually operate it.
So similar idea, different approach.
Right, and on the technical side, BEL system has this dual-band laser. Each band can be programmed separately, which means it can handle a wider range of missile seekers. It can also track and engage multiple missiles at the same time.
Sounds pretty capable.
It is. And BEL is thinking about the future, too. The system is designed to be upgraded so it can keep up with new threats as they come along. They also talk about its reliability and how it should have lower costs over its lifetime.
Which is really important when you're talking about defense budgets and keeping these systems running for years. So you've got HAL working on that specific system for the LCH, and you've got BL offering this homegrown solution that could work on a bunch of different aircraft. All this has some pretty big implications for India, don't you think?
Oh, without a doubt. Strategically, having advanced DRCM systems like these means that India's helicopters are much safer, much more effective. They can operate in dangerous areas with more confidence, which strengthens India's overall defense posture.
And there's the economic side too, right?
For sure. These projects, both the co-development and BL's own development, they're helping India become more self-reliant when it comes to defense technology. They're creating jobs, boosting innovation, and they fit right in with that Make in India initiative. Plus, having that 60% indigenous content requirement, that helps build up India's industrial base for the long haul.
It's a big step towards having a strong, independent defense industry.
Absolutely. It's about more than just protecting helicopters. It's about building a secure future.
Well said. So, to wrap it all up, it's pretty clear that DICM systems are becoming essential for keeping helicopters like the LCH safe from those infrared-guided missiles, which are a serious and evolving threat.
No question about it.
And all the work that HAL and BL are doing, whether it's co-development or homegrown innovation, it's all crucial for making that happen. But ultimately, this is about more than just the technology itself. It's about keeping our pilots safe, making sure our forces can operate effectively, and really, it's about India taking charge of its own destiny when it comes to defense. It's pretty amazing to think about how far things have come, and it makes you wonder, what's next? What's the next big leap in aircraft defense? How will we keep pushing the boundaries to stay ahead of those threats? It's a constant race, but it's one we have to win.
I couldn't agree more. This deep dive into DIRCM, it really makes you think about where we're headed and the challenges and the opportunities that are out there. It's an exciting time to be involved in this field, that's for sure.